Welcome back. Hoping everybody's having a wonderful day. Hey, like I promised you during our last lecture, we are gonna learn now an easier way of doing electron configuration. Now that we understand the basis of the quantum mechanical theory in respect to the orbitals and so on, we saw how to write the electron configuration that allow us to distribute the electrons around the nucleus, and we saw how we did it with the table for the orbitals diagrams and for the ordering of filling up the different levels, and we saw how sometimes the 4s comes before the 3D and so on. I'm going to show you now an easier way of doing it by using the periodic table. So that's what I mean with the base on their position on the periodic table. And once we do that, we're going to be able to identify the electrons that are valence electrons and the electrons that are core electrons. So let's do that by beginning with this problem. So we're going to write the full electron configuration and indicate the valence electrons and the core electrons. The valence electrons are going to be the electrons that are on the level that is the farthest away from the nucleus. The core electrons are going to be anything before that. If we were using the Bohr's model and we have the nucleus right at the center, then we have level 1, level 2, level 3, and I told you that you have 2 electrons on the first one, 8 electrons on the second one, 18 electrons on the last one. So the 18 electrons are going to be my valence electrons, and the other 10 electrons are going to be my core electrons. So that's the concept. The electrons on the last level, the one farthest away from the nucleus, that's my valence electrons, and those are the only ones that really matter. Everything else are core electrons, and all they're doing is kind of shielding the valence electrons from the power of the nucleus, because they are on the way. They are covering the valence electrons. So how do we write a full electron configuration using, let me show you first how we did it before, by using the diagram. And then I'm going to show you how to do it by using the periodic table. So let's begin with krypton. Krypton is number 36. So beginning with krypton, we know it's going to be 1s2, 2s2, 2p6, 3s2, 3p6. That's 10, 18, 4s2, 3d10, 4p6. So let's see, we have 10, 10, and 16, which give us 36. So that would be the full electron configuration. So how do we identify the valence electrons? Well, the valence electrons will always be the ones on the higher number. So what do we have on the higher number? 4s2 and 4p6. So those are my valence electrons. What are going to be my core electrons? Everything else, which are going to be all this in here and there, for a total of 10, 18, 28 electrons. So 28 electrons are going to be my core electrons, and 2 plus 6, which equals 8, those are going to be my valence electrons. Now let me show you something. So we are looking for krypton. So that's the one we're doing. And we are going to say but based on that, we know that this is our S block. This is our D block. This is our F block. And this here is our P block. So we can say, by using the periodic table, we can say that we start here. That would be my 1s2, followed by there, that's level number 2, 1 and 2, so that will be 2s2, followed by, we're still on level number 2. This is my P block, and there's 6 of them. And then we move to level number 3 on my S block, and there's 2 of them. And then I jump over, I'm still on group number 3, but those are my P's, and there's 6 of them. Then I move to period 4 on my S block, and there's 2 of them. Then, this is the part that is kind of different. I move into the D block. So this is my D block, and there's 10 of them. And the D block is always running one behind. What do I mean with that? I am on period 4, but I am on my D block. The D block always runs one behind, so not 4, but 3. Then I go to the P, where I go back to the 4, and all the way to number 6. So by following the periodic table and remembering the D run always one behind, then we should come out with exactly the same electron configuration that we had before. So let's see, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d. So that's one way to fill it out by following the periodic table. We basically start with number 1, with the exception of the helium, which is kind of a different, out of place. The whole first row is 1s2. And then you can continue with the ones on the different blocks. Another way to do this is you can take the periodic table and you can say, I'm doing krypton. I'm gonna look for the noble gas before krypton, which is gonna be argon. So you can say, I'm gonna take all these, 1s2, 2s2, 2p6, 3s2, 3p6, and I'm just gonna say that's argon. And then I'm gonna continue from there. 4s2, 3d10, 4p6. This is what we call the noble gas configuration, which is designed to help you save a lot of time, so you don't have to write any of these. You just go straight to the noble gas before the one you're looking for and write that down. So let's continue doing that with all the other ones to see how that works. So the next one we're doing, excuse me, So the next one we're doing is germanium. And germanium is going to be right here. So we're going to do it the easy way from now on. We're just going to do the noble gas configuration. So which one is the noble gas before germanium? So we're going to go back. Go back. So this is the noble gas before germanium. Argon. So we're going to say brackets, argon. And then we're going to take it from argon, and we're going to say 4s2 D10, but the D runs once behind, so 3D10, and then 4P2. So whatever is inside the brackets, that's gonna be our core electrons. Whatever is outside the bracket, that's gonna be my valence electrons. In particular, the one with the highest number. There's a whole different concept for why these are here, but we don't, the scope of this course doesn't cover all the way to that. So be aware then, for our purpose, that the core electrons are what's inside the bracket, the valence electron is everything that is outside. And notice this, it's telling us that the highest number is 4, so we should expect germanium to be on period 4, and it's telling us that we're going to have 4 valence electrons, which means we're going to be on group 4A. And that's what we are, group 4A, or what we call group 14. So the 4 shows everywhere. Okay, let's do another one. So the next one that we're doing is going to be chlorine. So once more, we're going to use the noble gas configuration. So chlorine is right there. So the closest noble gas going back is going to be neon. So we're going to do brackets, neon, and then we're going to take it from there. So it's going to be 3s2 3p5. So this tells us that these are our core electrons, and these are our valence electrons, and chlorine is supposed to be on period number 3. So no problem there, and it have a total of 7 valence electrons, which means it's going to be on group 17 or group 7A. And that's where we're going to find it, on group 17. So 7 valence electrons, that's where you see the 7 as your group. Let's do another one. Let's do the last one. So for the last one, we're doing strontium. So once more, we're going to look for the closest noble gas going back. That's going to be krypton. Krypton. Then we take it back from there. After krypton, we have 1, 2, 3, 4, and 5. So that's going to be 5s2, which tell us obviously that strontium is going to be on group 5, on period 5, and group number 2, because there's only 2 valence electrons on level 5. And that's what we have. Period 5, group number 2. So that's how we do the noble gas configuration, and that's how we know that these are going to be my core electrons, and krypton is number 36, which is 36 electrons. And these are going to be my valence electrons, which in this case is a total of 2 electrons. So that's how we do the noble gas configuration. You saw also how we can just walk across the periodic table and figure out based on the blocks, SPDF blocks, where we are. And remember that D block is always running one behind, and very soon you're going to learn that the F block is always running 2 behind. So you should be ready now to do that. And once you're done with that, you can do that now using the noble gas configuration. Actually, this is the one I was planning to show you. So you don't have to do that. We already did that, so we're not going to do it again. We did the concept of noble gas configuration. So you can work on this one. And once you're done with that one, let's see what we have on this one. So we're going to do it backwards now. Use the periodic table to identify the element with each electron configuration. And we have been doing that already, so let's just close it up. So given the electron configuration, can you find which element we're talking about? Well, we know we're going to start with neon. So beginning here, we're going to go 3s2 and then 3p5. So we're talking about chlorine on this one. Let's do the next one. We're beginning with argon. So we're beginning here, and then we're going to go 4s2, 3d10, 4p1. So we're talking about gallium. For the next one, we're beginning with argon again, and then we're going to go 4s2, 3d6. So we're talking about iron. Another way you can do it is krypton is 36, and there's one more. So that's 37. So which one is 37? Rubidium. So you can do it by finding the atomic number, using the number on the noble gas, or by just following the periodic table. So we have been practicing this. So as we were doing the electron configurations, we were doing that to double check that we were doing it right. So you already have some practice on that, so you have to do is practice some more. And once you do that, we're going to say that we're done with this objective. So you should know by now how to identify the valence electrons. When you do the electron configuration, it's going to be the ones with the higher number. If you have 4s2 and 3d10, the valence is the 4. If you have 5p6, 4d5 or something like that, the higher number is the 5, so the 5 is the valence electrons. And the core electrons will be anything that comes before that. And using the periodic table, you also learn how to write the electron configuration. Once we come back, we will go into the last part of this chapter, where we're going to see, using the electron configuration and other things we're going to learn about the periodic table, can you predict relative size, ionization energy, and metallic character for elements in the periodic table. And we will close the chapter with that, and that knowledge will become really important to understand every chapter remaining on this course. So until the next time, we'll see you soon when we come to the end of the chapter.